Hi, everybody. I'm Andrew London. Thank you for coming. I'm the program manager for Azure Remote Rendering. And I've got a background as a developer in the immersive space. I'm going to still claim that I created the first .gov VR website in 2017. I'm really excited to be here today. We're going to talk about some really cool things in the service, some updates, and some new features. Dev Days is a great opportunity to be able to announce these things because we're always focused on helping you, the developers, create incredible apps. So thank you for being here again. We'll begin by covering the service, what's been improved since our general availability release in last year, and some exciting and valuable new functionality. You might have gotten a glimpse of that yesterday in the keynote. Then we're going to check in with some customers who've been using the service and see how they've leveraged Azure Remote Rendering in their applications. And then I've got a quick live demo to show off. And if we have time, we'll do a bit of a Q&A. So Azure Remote Rendering released to general availability last year, meaning you can integrate this service with your apps today and expect the quality and reliability of Azure to power your apps behind the scenes. Azure Remote Rendering allows you to render high-quality interactive 3D content in Azure and stream it down to devices like the HoloLens 2 and Windows in real time. This lets you experience your content, your 3D content in mixed reality with full detail and no compromises. We built ARR because every detail matters. Rendering with Azure allows you to go beyond the limitations of your edge device, which can be constrained by the form factor and sometimes the power supply. Our powerful SDK is easy to use, and it makes integrating this functionality with your own apps just incredibly easy. So if you take a look at this 3D model, this is a 16 million polygon model of an engine. And not only does it have a ton of detail on the outside, but it's got a ton of detail on the inside. Every belt, every bolt, every weld is detailed. And as enterprises around the world are looking to see the value of mixed reality, they want to render and interact with models just like this. If a designer or engineer or customer could interact with a model at this detail on the HoloLens 2, it unlocks a massive amount of value. And while the HoloLens 2 is an amazing device, it's limited in its form factor, its processing power. It has similar capabilities to a mobile battery-powered device. This means that rendering 16 million polygons in stereo at 60 frames per second isn't really an option. Locally, the HoloLens 2 can render about 250,000 polygons. To work around this, developers and designers would decimate the models, and they would remove details to fit that constraint. In a lot of business scenarios, it's often the case that every detail matters. So if we decimated this down to the 250,000 polygon limit, you'd see something more like this. You couldn't use this low-quality model for design review or for selling to a customer. This locally rendered polygon limit is a blocker for key mixed reality scenarios. And that's why we built Azure Remote Rendering. It uses powerful GPUs in Azure, coupled with a highly optimized renderer, and it can render even the most complex 3D models. So to kind of put that in a figure here, if we look at the HoloLens 2, we mentioned it can render about 250,000 polys. With the standard performance of ARR, we'll let you go well beyond that. Supporting up to 20 million polys with 8 teraflops of compute. That's 80 times more. It's almost like strapping an Xbox to your head. But a lot of enterprise models are even bigger than that. Like, we're talking hundreds of millions of polygons. In those cases, we offer the premium service with 42 teraflops of compute. And that means it's capable of rendering over 1 billion polygons in real time. So not only do we go above the limitation, but we smash it. And so real quick, let's look at the workflow. First, you upload your models to your Azure Blob Storage. We accept both FBX, GLTF, and GLB models. more on that in a second. Then your application or service calls an API to convert the model into our runtime format. And this format's needed to make rendering as efficient as possible. Once the model's converted, we can write the converted model back to your blob storage. So models at rest are always in your blob storage. When you're ready to render, your app calls another API to start a rendering server. This is where you get to pick your premium or standard performance. And the server you pick is also available for you to then load and render your models from. And when rendering, the server sends those rendered frames back to your application, which is running locally on the device. And once those visuals get back to the device, those frames are composited with any holograms you might have in your scene. So you can really mix and match remote holograms for high poly content and local holograms for things like UIs or models that fit under those constraints. Our SDK, again, it makes this all super simple to do. If you're a Unity developer, you can work with remote objects just like they're a local game object in your Unity apps. The service is capable of providing an incredible amount of fidelity for your assets. We also provide some great functional elements here, from cut planes to spatial queries. We have outlines. We provide these features to enable tons of functionality, and it just comes with the service. Right? These are just available for you to tap into. Also, I want to mention the security of Azure. Microsoft invests more than $1 billion annually on cybersecurity research and development. And we have over 3,500 security experts that are focused on data security and privacy. So this is a huge benefit to the Azure service. And they also have support available 24/7, right? So you can rest assured that the products you build with Azure Remote Rendering will be rock solid and we'll be there to back it up. Another note is we've expanded our region footprint that supports Azure Remote Rendering across the world. So in addition to the 4 regions we started with, we now cover Southeast Asia, UK South, North and West Europe, Japan, and Australia East. So it's really widely available to use. It's pretty much everywhere if you need it. I also wanted to take a moment to introduce you to ART. ART is the Azure Remote Rendering tool. And ART serves 2 roles. One is we've got all the source published on GitHub, so it makes a great desktop Windows sample application that demonstrates how to integrate remote rendering into your own products. It can also be a useful tool to get basic tasks done. I use it all the time for like uploading source assets into your Azure storage, running conversions. You can even create rendering sessions. And we're going to see ART later during the live demo, so you'll get to see more about that. I definitely recommend taking a look. We provide pre-built binaries if you're looking for the absolute quickest way to get started. ART supports uploading files, converting 3D models, starting premium or standard sessions, rendering converted assets, controlling session durations, interacting with your remotely rendered content through raycasting, changing material properties of selected parts. You can launch the ARR inspector. It does everything you need to do in a quick one package. And we're always updating ART. As well as ART, another tool that we provide is the ARR inspector tool, right? And this is a web-based tool that allows for inspecting running Azure Remote Rendering sessions. This can help debugging greatly. It provides an interface to inspect the structure of the scene. It shows log messages, and it monitors live performance. You can even pause so that you can carefully inspect a specific state. So there's some great tools around it too to help you in your development. As kind of a quick FAQ, just to cover the basics, Azure Remote Rendering supports HoloLens 2 and desktop Windows. Our network requirements are 50 meg down, 10 meg up, and a maximum latency of about 80 milliseconds. We recommend 100 down, 20 up, and if you can get latency below 40, that'll give you the best experience. On-prem solutions like Azure Stack Containers and Databox Edge aren't currently supported. But one thing to note is using multiple devices with Azure Remote Rendering is super simple. Each device connects to its own ARR session, but then you would just use some sort of networking utility to create a multi-user app as you would without ARR. And like I said, we support FBX, GLTF, and GLB files for conversion, but those of you in the keynote might know where I'm going with that in a moment. Another frequently asked question we got is, what are the differences between holographic app remoting and Azure Remote Rendering? And these are both potential candidates when we have things that are too big to render locally. We always recommend starting with Azure Remote Rendering because it's a turnkey solution that's backed by Azure with the SLAs and reliability to match. With Azure Remote Rendering, the app still runs on your HoloLens, and it brings in select content from the server. This is a different implementation than holographic app remoting, which requires the entire app to render on a remote PC, and it streams to the device. So start with Azure Remote Rendering. If you find a reason it doesn't work for you, if maybe you need a different file type that's supported, or you want to leverage some unique rendering features that aren't in remote rendering, then that would be an opportunity to use holographic app remoting. Another thing to mention is holographic app remoting is a library to build your own applications with, where Azure Remote Rendering is a service, right? I want to talk a bit about what we've been up to since our general availability release last year. Some of the top feedback we received from developers was shortening the time rendering sessions take to start. So we focused on improving the startup time for standard sessions with a goal to take it from 3 to 5 minutes to under 10 seconds. And we did that. We did it by optimizing the entire virtual machine allocation pipeline. And we set up a warm pool of rendering virtual machines that are kind of on standby, waiting to handle that request. So when it comes in, we can start that session quickly. Another priority based on customer feedback was improving hologram stability when local and remote holograms overlap. So here in the video, you'll see an example of this instability. We've enabled a local pose mode for the HoloLens 2, which provides a fundamental gain in hologram stability for local content, including UIs, like menus. You can see that difference is pretty awesome there. In the old mode, the local content was rendered using the same predicted pose as the remote content. In the new mode, local content is composed separately into a pre-transformed remote image using the same local pose that any mixed reality app would use. Another improvement is that we now support OpenXR. So supporting this industry standard makes sure that Azure Remote Rendering is compatible with this broadly accepted API. So the big news, we've got this special opportunity with everybody at Dev Days. So we've chosen to announce a new feature and release it here. You might know where I'm going if you saw this yesterday. But what if we have a data set that was captured in a non-polygonal format, right? Converting files to a polygonal mesh takes effort and a lot of artistry. It can be painstaking to try to find that right balance, even if you have a lot of resources to render with. Sometimes raw data just doesn't convert in a visually accurate way. So to not lose detail, what if we could go directly from a capture device like shown here to Azure Remote Rendering? Well, now you can. We support point clouds now in Azure Remote Rendering. So we're announcing the public preview for this. So now everybody can go and leverage these point clouds in your Azure Remote Rendering apps today. And the great news is you use it just as you would a polygonal mesh, right? You process with our converter and you just render it remotely. So to get more into that, we've implemented this feature in a way that requires no additional lift from developers, right? These point cloud file types are all handled exactly the same way in your workflows as how we've handled polygonal meshes in the past. You just upload your now.e57.ply or .xyz file to the blob storage, run the conversion as you would with the PowerShell script or our beloved art. And this will create the same output, which is that .arr asset file. Then you can use either the SAS URI or for the asset or load it based on blob storage ownership. That's it. So literally there's nothing you have to do except have a point cloud and then shove it through the normal process. In the private preview, we worked with our partners to understand the needs and capabilities that would provide the best value. And something we kept hearing was the value of rendering hundreds of millions or even billions of points. So we listened, and today we support up to 2.5 billion points on the premium service. That's just insane. I haven't seen a data set that goes that far yet. I'm going to show a 2.2 billion point scan later, but yeah. This means you can take entire sites, super dense scans, large spaces, and you can view them in mixed reality. The benefit here, I think, for architecture, engineering, construction use cases are huge, right? You can conduct asynchronous site walkthroughs, design future state on top of current actual scan of current state. For education, you could visit World Heritage sites in crazy amount of detail. We spent a lot of time figuring out the best fit for how to handle point sizing for near and far field representation, right? The trade-off here is you don't want to lose any detail, but you want to provide something that gives you a continuous seeming visual surface, right? So we've found what we think is kind of the Goldilocks zone there, but we've also given developers access to be able to change those point sizing, right? So they can implement how they see best fit for their needs. Something else that's worth mentioning is that you can load these point cloud assets alongside your polygonal meshes or the other way around, right? They're both compatible at runtime. You can just load them as you're loading multiple assets. You know, Azure just sees it as another request to load, and it'll just do it. And so this functionality is awesome if you've created a big library of polygonal mesh assets and you want to leverage those assets against a point cloud scan. So if you're doing layout or design and you have a table or something and you have a point cloud scan, you can load the table that's a mesh on top of your point cloud scan. This is the treehouse that I scanned, and then that's our dear sweet built-in engine, right? I don't know why you try to fit an engine into a treehouse, but maybe that's some sort of new product. So with that said, I wanted to get into some customer examples and check in with them, see how they're using point clouds and ARR overall. One of the most interesting here is HoloLab. So HoloLab is taking geological surveying scans, and they're rendering them with Azure Remote Rendering. This is the scan that I was talking about. It's 2.2 billion points. This is the entirety of Mount Fuji that you're seeing on a HoloLens. And I'm just gonna let this play for a second because it gets insane. Okay, you're seeing Mount Fuji from far away. And then as you get close, those are all trees, right? And by the way, the jittering you're seeing is just because of the way the mixed reality captures the content. That wouldn't be visible in the headset. But what blows my mind here is, as we explore Mount Fuji, which just sounds crazy to say, there's the cone, and there's like a research facility on the edge right there. Like, we'll get closer. Like, there's an entire research facility. And I was like, well, that's crazy. I mean, that's probably a pretty cool job to have, to sit on the cone of Mount Fuji and conduct geological research. And I thought that was it, but there's like another research facility on the other side of the cone. And this is all information that we can see and interact with because how much data is being presented in front of us right now. There's that other research facility. That looks kind of like a James Bond villain lair. But just the fact that we can see so much, we can understand so much about this from the geological scans that are going on. There's a big initiative over in Japan to capture as much surveying data as possible, and they're using LiDAR scanners. You can see the value that having point cloud rendering supported in Azure Remote Rendering brings to these use cases. Another example I wanted to show, I'm getting a weird kind of, okay, cool. Another example I wanted to show is our partners over at Case Western. They're using Azure Remote Rendering, and I think this one's crazy too. I think they're all crazy if that's not awesome.
Thank you for having us. I'm Jeff Malacher with the Interactive Commons at Case Western Reserve University, and I'm here to talk to you today about what Case Western is doing with Azure Remote Rendering point clouds. And at Case Western, we are always focused on pushing the limits of what the HoloLens can do with regard to what we can display and what level of detail we can teach. We've been working in HoloLens since about 2014. We were the early educational partner with Microsoft on the HoloLens, and we are especially focused on large shared classroom experiences. And there is a wide range of those that we create. These span anatomy, physics, crystallography, astronomy, and even dance. Now, Microsoft Mixed Reality Services have provided us with a means to grow our experience beyond just the proof of concept to actual classroom experiences. Now, Azure Remote Rendering continues to grow, and as it does, there will continue to be more and more opportunities for what we can do holographically. Now, a large and unique challenge for us comes from a wide range of data that we get. Now, this can include medical imaging, seen here as this scan of a person with some serious scoliosis from the Siemens Cinematic Rendering tool, but not just limited to STEM. For example, art history, as shown in this digital laser scan of the Red Monastery. Each millions of points, the left several million, the right hundreds of millions. Our professor, Betsy Bowman, a leading expert on late antique Byzantine and early medieval Egyptian art, had obtained and had in her possession new scans of the newly restored 5th century Byzantine church, the Red Monastery, and found her way to us asking if there was some way we could visualize that in a class digitally. And that culminated in March of 2021 when students entered this ancient church virtually in HoloLens 2, dozens of students experiencing the grandeur and detail of this ancient site. But of course, the process of transforming that laser scan data into mixed reality experiences was far more complicated than expected. First off, the amount of data was in the billions of points that could be used to create that digital twin. The model needed to be built to scale and with an incredibly high level of detail to meet the learning objectives. For students to have, as Dr. Bowman put it, an embodied experience in the church and a sense of proportion in relation to oneself. So what will ARR point clouds bring us in the future with respect to this? Ultimately, time and detail. What would have been weeks of conversion to take this into data into something usable can now be accomplished in minutes of processing. And that would be full detail displayed in lens of millions or even billions of points. Here you see the result of that. This is a 250 million point E57 point cloud data file displaying in lens with roughly a half hour of processing time needed. And you can see the detail that we achieve as we go up close with this, where this would have been very difficult to create otherwise. E57 point clouds or PLY point clouds dropping into lens easily and looking beautiful and complete in a very short amount of time. What you see here is that earlier scoliosis model, also millions of points. And you can see the detail with which we're able to get this and this processed in mere minutes to get to Lens in a way that we can view. We are currently investigating Azure Remote Rendering and finding use cases to augment our developers with it. We look forward to working more with Microsoft to see where this journey takes us. Thank you for having us.
Weeks to minutes, and no degradation of quality. That should just speak for itself, right? I think that's kind of the big win here. Thanks, Jeff. Another customer that is using this is Visor Dynamics, right? So this is Dan Fuster to talk about how they're using it.
Fuster, Software Delivery Manager at Visor Dynamics, and here is a brief showcase of how we and a partner of ours, Fexelon, utilize Microsoft's Azure Remote Rendering technology in our solutions.
Just super cool. And lastly here, I've got the one and only Renee Schulte from Valorum Reply to talk about some of the, and he's the Director of Global Innovation at Valorum Reply, to talk about how he's using point clouds, and they are using point clouds.
Video of a brand new Azure Remote Rendering feature that allows us to take point clouds as they are and we don't have to process them into geometry in between, right? So what you see here is a 3D scan we did of our Milan office, or actually one of our Reply Milan offices, and I've shown it in a previous video before, but in a previous video I had to convert it from the point cloud scan into an FBX model in order to actually visualize it with the Azure Remote Rendering service. So what we did here, basically, we used our Boston Dynamics Spot robot, or one of them, and we have a Leica LiDAR scanner, a laser scanner mounted on the back of it. And here you can see the robot, and here you can see the robot, and so on. And there are multiple stops here again. And so basically it walked around this area, did 3D scans of the whole area, and then we were able to actually just basically, it's automatically stitched together, and so in the end we get a 1 billion point cloud 3D model. And as you can see here with the branches of the tree, it's super detailed, and it's pretty amazing because with this new feature of the Azure Remote Rendering, we can see all the details. We don't have information loss because of the conversion into a geometry format like FBX. Look at this, we can even see the toilet house here, or the stairs. Like, look at the detail, right? It's pretty impressive. We even see all the small details here. And again, I can walk around the building. You might be able to see a bunch of folks all over the place, or here the umbrellas and things like that. So full detail is maintained. Also the little reply man, and no manually model conversion is needed. So we can even go inside of the lobby here. We can see the hand sanitizer right there, and all these details of the lobby, right? I can walk inside, I can see all of these details. And again, no manually model conversion is needed. I don't need to convert all of this into a geometry format like FBX, and I can render it directly. And this, again, I have to use the premium tier of Azure Remote Rendering, and this is around 1 billion polygons, right? So there's no information loss, basically, coming from the billion points. We basically get 1 billion polygons as well and have the fullest, highest detail. Amazing feature with Azure Remote Rendering, and looking forward to do more with it, because this saves us a lot of time and full information is maintained. And so thanks for watching, take care.
Two things on that. One, did you hear all the birds in the background? Sounds like a really beautiful place. Two, he said that they were putting a Leica scanner on the back of one of those Spot robot dogs. So they created this scan in an automatic way and just had it survey the scene. That's incredible, right? You can imagine how you could update your data sets pretty rapidly on a regular interval and then bring those data sets without having to convert them to polygonal meshes and just throw them up into ARR, right? So that's a really quick turnaround for needing things pretty quickly. It's always so inspiring to see how our developers and partners are using this stuff, because we put it out there and then it gets used in ways we hadn't even thought. So with that said, I think it's time to show a little live demo now. So let's play with point clouds. So over here, this is our beloved art that I was talking about. And we've got a session running. So I'm going to load a model from our storage here. And I actually came into this room on Monday and did a 4-location scan that created about 43 million points. So this point cloud that you can see we're loading at the bottom, when it comes up, it's going to be this room. And we'll be able to traverse it and talk about some of the details and decisions we've made for the visual side. So I can zoom in here. And the first thing is just look how complete this room looks from the outside, right? I mean, it's almost airtight for a point cloud. That's kind of crazy. And then there we are, right? This is where you're sitting. The tables have been rearranged, moved, and a bunch more chairs added. But yeah, this is kind of your perspective right now, except darker. And you can see, one of the interesting things we've chosen, if you take a look at this chair here, is we're not using circles or squares for our implementation, right? We kind of chose to mush them together, and we're using squircles. And some thought went into that, because squircles allow you to have almost the same coverage area as a square, but with the visual accuracy of a circle. And so we found that using this specific point representation gave us about 93% the same coverage as a square. So we figured this is the best kind of mix between being able to have a surface that's solid, but also having the most detailed visual accuracy as possible. And like I mentioned earlier, we've added some adjustments here, right? So we can change that point size dynamically. So you can see I can dial that down, and that's kind of what I'm talking about, right? If we go to the smallest point size, it's technically more visually accurate, but you lose surface, right? So to use these in a way that's going to be beneficial visually, we've dialed it into what we think is the best implementation. But you can also go crazy with it, right? If you need to, you can make them huge. It depends on the density of the scanning source. So this gives you some adjustment to play with that to get the best out of that source scan. I think one other thing I'll show, just because it's really cool, is the treehouse, right? Let me remove that model, and we'll load treehouse 2. Now, the thing that's crazy about this, and I mentioned this yesterday, is the LiDAR scanner, that laser beam just keeps going, right, until it stops. Some of them can scan, I don't even know, like, it seems like half a mile. But when we go into this, you'll see what I'm talking about. So I went out Monday and captured this as well. And this is the treehouse on campus that is just gorgeous. And I only set up, this was a 3-point scan. I've set up a scanner here, and a scanner here. But you can see the amazing detail here in the treehouse. And then when you look this way, you can see how far out it went, right? There's like tree surfaces. It caught leaves all the way over here when I was, capturing from over here. So, these massive data sets are just no problem for Azure Remote Rendering. And you can see how fast we're moving around, right? This is a live session. So you can expect this performance on your HoloLens too. So that's kind of what I had for the live demo. If anybody wants to see something specific, here's that ARR inspector tool. I can show you how we can monitor the performance of this, right? We can see the log, you can capture your timing data, you can collect your debug information, and you can add more performance queries. So this is a pretty robust tool here. If you're trying to get started quickly, again, I just want to reiterate that the ART tool is great for that. This was me just having fun with scanners. I just needed to include this because it was me nerding out and having a great time. This is a Navis scanner, and as you scan, it literally creates the point cloud map as you walk, right? So these tools are getting more advanced. There's LiDAR capabilities in your iPhone if you have a 12 Pro Max or above. So you can take scans with that and just throw them up. So with that said, I wanted to open the floor up a little bit, see if anybody had any questions about the service or anything they'd want to know. So we can do a little Q&A if anybody has anything. Yeah, please. You, sir.
Point cloud.
Yeah, it's the first step towards work inside of these things because you can interact with these with raycasting. On the local side in your Unity application, you can create functionality to say, hey, I'm marking this as a wall, or I'm measuring this space to this space. So that's another benefit of Azure Remote Rendering being a mixture of your remote content and your local content. So that app that you're building, it can do anything. And then this source of data being raw and true lets you build on top of that. Yeah. Yes, sir?
Do you see this?
Well, that's why we built ARR, right, is to get around the limitations of those edge devices. So that's a great question about whether this is a gaming technology or industrial. I see it more industrial use case driven, right? Because it was built originally for the HoloLens. We support Windows desktop as well, so we're seeing some exploration of use cases there. But mainly it's the benefit of getting this data set rapidly into something that you can, in an immersive way, navigate and drive through. So I think it's more the latter. Any other questions? Yes?
Probably on my side, just a joke that point of view. Our customers, they manufacture physical pieces. While manufacturing this, or they need to measure. We are guiding our operators to take a look at the piece, hologram on top of that, and we show them what they need to measure or what they need to scan. We are actually building a prototype where we are retrieving the points from the scanner while we are measuring, and we display accurate if it is within tolerance of the measurements that we're taking.
Awesome.
So we are displaying the points there. I do see a limitation because, for what I understand, I'm not quite convinced. I need to upload the points cloud. Do it real time.
Yes, yes. You can get near real time with it, but you absolutely need to upload it to your storage, run the conversion, and then it's usable. And depending on your point cloud's file size, that conversion can be really quick. Right, the treehouse that you saw, I think that took about 6 minutes. So your question about how to get these usable as quick as possible, it just depends on that time frame you need, but these can be really quick. How many points on average are your scans usually?
Well, it depends on the size. If the resolution of these scanners is very like 50 nanometers, so you can get like 2 million pieces.
Oh wow, yeah.
So if you are trying to measure a wing, for instance, or a fuselage, then you're talking about billions.
Yeah, yeah.
It depends on the size of the piece.
Yeah. Yeah, I'd say you should give it a shot and see how long that conversion takes, because you might be able to get it back down within that session time where someone's still there, and then they could anchor on top and place it and do those measurements that you're talking about.
Great.
Yeah, thank you. Yeah.
Without having to be connected. What is Microsoft doing?
Yeah. So the question is, how do you handle if no network connection? In those instances, I might refer you to the holographic app remoting, right? Because you could use a PC box, a PC nearby, and over Wi-Fi you can stream from the PC, and that wouldn't require having a network connection up to the cloud. Oh, absolutely. I mean, if you have a network that's addressable, we have conversations all the time about people using Azure Remote Rendering over 4G and 5G networks. So it's not Wi-Fi dependent. As long as the network is performant, then you'll be able to get the results that you need from Azure Remote Rendering. I was just speaking to if there was no network. Yeah. So that's holographic app remoting, right? And that runs the whole app on a PC, on a remote machine, and then you can stream it over Wi-Fi. Well, it's actually it's an open library, so you can implement it how you need to. So you have some control over the rendering there. So I'm not totally sure, but I think it's potentially optional. What do you think, Jonathan?
So with holographic app remoting, you write the app.
Oh yeah. And the question was point cloud support with the holographic app remoting.
Yeah, holographic app remoting.
Boom. Cool. Do a little mic check. Mic check. Now it worked.
Thank you, sir. Any other questions? Well, I really appreciate everybody coming today. One last thing I want to plug here is where should we go next, right? We're always looking for feedback to understand how the developers can get the most use out of this tool. If you see the bottom here, we have an aka.ms ARRFeedback, and this will take you to our Azure user voice site. Please be vocal, let us know. We're always listening to our developers and would love to understand how it could better fit your needs. With that said, thank you for coming to the session.